Alright, so hopefully we should be live now. One sec, however it appears my camera has died. My overhead camera I was using, that's a shame. Let's see if I can bring that back to life. Yes, there we go. And zoom in on that. Perfect. Okay, so just want to quickly ask the audience, how is the audio? Well, actually, yeah, how is the audio on here? Because I don't actually know how good it is. I mean, can you guys hear me? And also, can you possibly hear the music? I don't actually know. I've recently changed my streaming setup a bit, so, and according to OBS, there is literally no audio coming from my Chrome tab playing the music. So, let me post that in chat. So what I thought, oh actually let me turn my mic down a tiny bit, there we go. No music, only you and keyboard typing. Huh, okay, that's what I thought it would be like. So it looks like we might not have any music this stream, which is going to be a bit of a shame. Yeah, that's a bit of a shame. No music. Oh boy. Okay, well, let's just assume for this one there'll be no music. Just purely on the grounds that my computer's being really strange right now and not wanting to show any music. So yeah, sorry about that. Anyway, so what I said I was going to do... Yeah, I know, I'm sorry it'll be very boring, but, you know, I'll fix it for next stream, you know. It's partly due to the fact that I've switched from using Pulse Audio to using Pipewire, and I'm not sure OBS is... I'll quickly put this up in here. So I'm not entirely sure if OBS is okay with that. So I've got my desktop audio slider on here, and if I play some music through Pretzel Beats, you can see there's like literally nothing coming in through this channel. So that's my current issue, but I thought that would happen. So what I was going to do in this stream was essentially, let's see if I can quickly flick over to my camera. So as you know, this is my M2 over here. Ooh, I've also realised that this is upside down to how it normally is. Okay, so normally the M2 would be on this side. I don't know, the camera view seems to be flipped. Oh well, not a big deal. But anyway, what I was going to do this stream is my M2 is basically only got CAN support, and that's partly due to the driver I've written for my Passthru API. It does also support K-line, and I was planning on adding that today. So essentially we've got an extra third wire here, this little red one here, this extra one, which goes to the K-line diagnostic point on the ECU on here. And I'm planning to see if I can get that working with tools like Vimeo. So I shall actually go to both screens now. So here I've got I did some planning just before we started this stream, so I just did a few bits of checking out, seeing what works, initializing the call to basically initialize the K-line on here. And here you got Vimeo up and running, saying that it can't establish to a connection via K-line to my ECU, which is expected because I haven't even added support for that yet. So I say let's just start this. So I've got two Visual Studio Code tabs open. I've got one here which is on the Rust driver side, and I've got another one on here. Oh wait, wrong one. This is the wrong one. And I've got another one here which is for the firmware, which runs on the M2 itself. So I suppose I'll just get started. I mean, you guys are welcome to ask any questions in chat as usual. Like, I'm not stopping you from doing that. I apologize again for no music, but yeah, this stream is going to be a bit of a painful one. Especially, I've heard doing K-line is not exactly fun. and just I've got my cup of water as well. Keeps your throat hydrated, all good for you. So, ignore the activate Windows thing over here, by the way. So currently, if I go ahead and ask it to establish using K-line, oh, where's my combined tab? There it is. Go ahead and say launch. We get a quick message up in the driver logs, basically saying I've got a command saying init LIN channel, and currently says error not supported because it's a to-do message, and that to-do message comes from the device firmware, where it is channels.cpp, and it's like right away at the bottom of this. Here we go. So I now need to unpack the arguments for this. So I believe the way I wrote this in the driver code was, if I go to iosctl, here you go. So for fast initialization, which is what this wants to do, I believe, init LIN channel, fast init requested, yes, it's doing fast init. Fast init, there should be 4 bytes, which is the channel ID, then 1 byte, which is the initialization type, and then input data to send to the device during the fast init request, which is the rest of the payload. So I shall go ahead and extend that. Unsigned long channel ID equals little Indian decode, which is this little helper function I built to easily unpack all the args from an input com message, and source shall be message args 0 because it's the first argument in there, and I believe that should take 0 to 4. Then uint8 wake up type. We're going to call that, so that's the, no, actually we'll call this init method. Init method equals args4, and pointer to the rest of the args, data, no, I need that to be message args4 is equal to, and message args5. And we'll just quickly do a byte here to basically say how long the args size is. Arg size is equal to message arg size minus 5. Yeah, there's 5 additional bytes. So let's quickly go check all this. So char buff 100, and I'm just going to quickly print this to buffer. PCCom log message, error not supported, and we're just going to quickly just throw the buffer in to there. sprintf init LIN init requested. Oh wait, shoot, I'm formatting this like this. There should be buff in front. Init method %d arg size %d channel %d. So that should be channel ID. Nope, wrong way around. Init method arg size channel ID. So now I have to disconnect the M2 from my VM. So virtual machine redirect Arduino, take that out, and we can upload it. Ooh. And we can go ahead and upload the firmware to that. Ooh, I want to upload. By the way, how's the text size on the screen? Should I zoom in a bit? Or should I keep as it is? Cool, so I shall now re-enter the Arduino into the VM, and we shall launch Video again. And we're going to select CR3 up, which is, there we go. And quickly go ahead and connect to that. Okay, so this is now correct. So here we go, we now see status error not supported, but we see our message that we printed in firmware. So LIN init requested init method type 1, which is fast init, arg size is 4, and channel 1. That's in, yeah, okay, that's fine, that's expected. Cool, so I can quickly get rid of all this now. And now we can do I'm just going to put a comment here, 5 board equals 0, fast equals 1. So now check if the LIN channel is null, because if it's not null then we can't do that. So if this, if K-line channel is null pointer, then we quickly PCCom respond error, so I can get rid of all that. Respond error, and we say error is invalid channel ID, and we set null pointer to be args because this basically self-explains what happened. Now let's quickly go here to COM channels. And just create a quick void which does the wake up. So int ID uint type, and then data len, or data len uint request len. So let's just quickly add that in. Actually no, you need to be in ISO914 channel. So now here comes the fun of implementing the wake up method. So we go here and we slap you into here. Actually, I'm gonna create, because I'm just gonna create this on here. So you create it as a virtual method, and then in CAN and K-line it's just not supported at all. So in CAN we just do that, and in ISO 15 we also just do that because it's not supported for those two channel types. PCCom log message, wake up started, just so I know. Shoot, where are we going? We're going to no we're not, we're going to channels.cpp. Else, and then we basically cast now. Oh, and we also want to do another check quickly up here to make sure that the channel ID is correct. So if channel ID does not equal K-line channel ID, then we also want to return the same error, because this basically means that the channel is not the same. So ID mismatch for K-line. Check if K-line is null, then we go ahead and say K-line channel wake up. and we want to give it the type, so we want to give it the init method, and we want to give it the args and arg size. Cool, so I believe that's all that we need to do with regards to this. Now I have to implement the wake up. So, I believe on here I had a K-line ND2, OBD serial begin. Return true there. So yeah, when the channel is set up, there is no... so when OBD channel is initially set up, there's the initial serial device, and then there is absolutely nothing else. So we just basically say serial.begin, but then other than that there is nothing. This just basically sets the status light on the M2 to be on. I'm just thinking here. Now also there's one thing that I want to do, so essentially I'm copying some code from this existing OBD 9141 library, which is meant for the M2, because I'm only going to be using bits of it and the rest of it will be handled completely differently. So I'm just going to go ahead and copy some bits and bobs around. So channels.cpp, where are you? comchannels.h. Private void where are we going? We're going back to channels. Oh yeah, also by the way, should probably say apologies for not being online lately, or just kind of like being off. I've basically had many exams, finished my dissertation for university, so things have just been really busy, and unfortunately things might not be back to normal until like the end of May at this point. Pin mode, TX pin, output, digital write. And then ooh, have I not stored our baud rate? I don't think we have, so let's quickly go ahead and do that. So that should be a ooh, but what date that should be? There should be a bool. And we set that to 0 on startup. Cool, so I also want another void here. We got 6 people watching currently. Hell yeah. Okay, I'm just like not really with it right now, but so I need to find how they do fast init on here. Okay, so this is where things get different from the standard OBD library that Macchina provides, which is why I'm copying some of their code and I'm not. Right. We need to go here to wake up started, and we need to go ahead and do this set port false. Oh wait, we need to, depending on the type. If type is 0, to do 5 baud init, and then else, which is fast init. I'm just going to respond here. So pccom respond error. Oh shoot, I've forgotten this. Oh yeah, error is easy. Message init LIN channel, error ID is error failed, and the error argument will be 5 baud init to do. So we go ahead and say this set port false, this set line true, and then we want to delay. I'm going to bust for 3 seconds. So I swear on the Passthru API there is a specification for this particular IC T idle, I think it's called. Bus idle time required before starting the fast initialization sequence. Yes, so it would be delay this tidal. And then we do this set line false, delay 25, and then do the next bit, set line true, delay 25. And then enable this set port true. And then we take our message args, we can do we also need to do a function here for checksum, and that will also depend on whether there is no checksum involved in line, I believe. And then void write cs uint buffer how are they calculating? Oh yeah, okay, this is standard. So uint res 0, and for uint I is equal to 0, I is smaller than len, I plus plus, and then res plus equals buffer I. And then we do buffer at len is equal to res. So I need to remember to keep subtract, so this will be the full buffer size. Go here and we set another one saying void write data uint buff uint buff len, and then bool do checksum, because sometimes apparently you don't need to do checksum on this. I'm not entirely sure, but I remember reading something about that in Passthru API, that occasionally you don't need to do checksum. So quickly go back here. Voidy do that. So allocate new buffer. Okay, so we just need to quickly do this if checksum. If do checksum. Then we do that. Else this serial obd serial write, and we just write directly the buffer and bufflen. Yeah. And if do checksum, then we have to calculate checksum first. So uint new buff equals malloc bufflen plus 1. I believe that's how malloc works. I can't remember. Void type, void star cannot be used in today. Oh, okay, we'll just cast. Delete new buff when we're done with that. Actually, we'll do it without malloc. New buff equals bufflen plus 1. Yeah, okay, I was right the first time. So new buff is equal to malloc, and then bufflen. Let me go ahead and say mem copy. So we mem copy from old buffer to new buffer. So destination would be new buffer 0, source would be buff 0, and length would be bufflen. Then we do checksum. This write checksum. Buffer would be new buffer, and length would be bufflen. And then we go ahead and write the new buffer. So this obd serial write. +1. Cool, so after we write, then what do we do? So we want to write, so this write data. So buffer would be request, and it would be request length. Bool to checksum will be true, and to do handle no checksum. And for now we're just going to wait for an error. Log message. I'm actually going to wait 1 second, and then we're just going to read everything which comes into serial, and then we're going to dump it. And then we're going to say this failed. Respond error. Just whilst this is a to-do. Work in progress to do. So delay 1000, and then while serial, this obd serial dot available. Actually, we're just going to create char buff oxoo. Let's make that 5 characters. Right, let's see how that works. I'm just going to delay 100 just so the device has got some time to wait. Okay, virtual machine, redirect device, this. Go to VS Code, upload. So I'm expecting to see some bytes come back, but we shall see. Okay. Reinsert this. Close this. Ecoot. Oh, well, it would help if I'd actually shut down the communication server Vedimo had with my device prior to starting this. Okay, KK. Launch again. Cool, now we're working. CR3. Okay, so this is interesting. We're not seeing any bytes come back from the device. That's a lot of nanoseconds. It took 1 second to execute, and we didn't see any data coming in from the LIN channel, so something must be wrong. I'm just going to quickly get rid of it. So why don't you want to do fast init correctly? Am I reading the time period correctly? Where's my Passthru API documentation? Let's quickly see what it's set. So the one I'm curious about is this one called tidle. So I'm gonna quickly see what what it's set tidle to on here. Oh, it set it to 0. That's unusual. Huh. Now why would it do that? That's not supposed to do that. In fact, all of these seem slightly wrong. I'm just quickly reading on here. Oh, because I haven't applied TINL and TW up. Let's quickly do that. So modification, undirect that, and this should be a very simple fix of going here, and where we have this delay. So this will be this TINL, and this will be this TWUP. Let's quickly upload this. Cool. Redirect the device and do this all over again. Nope, again I'm still seeing no data coming in from the ECU. That's mildly worrying. Actually, let me see if I've hooked this up correctly. Let's go to this white cable here. Yeah, so K is this one here, which goes to this pin on here, which then should go to the front of the ECU, which it does. Also, one thing which is confusing me as to why. Wait, let's see if I can find it. Here we go. Why is it trying to start on ISO 9141, but then using fast initialization? Because according to the specification, this should never use fast initialization. Only KWP2000 should. So why is video mode trying to do that? I have no clue. Okay, time to try for a different tool. Let's quickly try for INPA, see what that does. Nice. Okay, whatever. So access is denied. That's the first time I'm seeing that. Open file location and just run you as an admin. And now it's just not using the device at all. Anyone know of any good pass-through applications which like use K-line so I can test with, because this is going to drive me insane. Oh yes, hello, you are back. Yeah, I know, it's been a while, I'm sorry. Oh, also, should probably make an announcement. See, look, wait, quickly, before we do that. See, on here, the interface in Vedimo says K-line KWP 2000 PE 10_4, but when I try connecting to it, the application seems to think that it's ISO 9141 which it's connecting with. The only possible thing I could think of is that I've possibly got the protocol flags mixed around, so let's quickly double check that to make sure I'm not a complete idiot. So that wouldn't be on the firmware side, that would be on driver side. So quickly bringing up the PDF for this, and we say ISO 14230. Okay, so ISO 14230 should be protocol value of 4. Cool. If we go ahead and look at protocol ID, so this gets passed down to pass-through connect, which then turns that from raw. Go have a look at this. Here we go. So look, ISO 14230 is 4, just like it says it is here. And ISO 9141 is 3, which is what I've got here written down. So why the hell is it doing that? That's bizarre. Why would you do that? Awesome, that's it. So yeah, I genuinely have no clue why Vedimo is trying to launch with ISO 9141, even though it says quite clearly here it's going to try using K-line. Sorry, Keyword Protocol 2000 PE. That's bizarre. Unless it does something first. But then again, if it's using ISO 9141, it should never use fast in it. It should always use 5 baud in it, because that's what's only allowed in ISO 9141. Let's quickly Google this. So, ISO 9141 fast in it. Is this even valid? Stick channels. Fast initialization. Oh. J2534 toolbox, you say? Okay, let's try downloading that. Oh, brilliant, it's Passthru Technologies, great. Let's quickly close the demo. Now the question is where to download. There we go. Click here. Keep. Okay, so whilst this is downloading, quickly want to go over a a very nice announcement, which is that I have ordered all of the components for, let's see if I can bring it up on the screen, for my gearbox controller. This is no longer what the PCB will look like. The PCB now actually uses automotive grade components. Admittedly, due to the silicon shortage, I've had to use older ones because the new ones are like got a 72-week back order. And here is my little Tinsy controller. So that will essentially be plopped in like this. Come on. There we go. It should be in like that in the real board, and that should all come next week. So I'll keep you guys all updated as to when I plan to do a stream, and I might do some soldering live on camera. Don't quite know. We shall see. Anyway, this is now finished. Cool. So J2534 toolbox should be installed now. What? Do I have to log in? Oh, I can hit X. Okay, that's fine. Okay, so what do I do here? Tools. What? How do I use this? Ah, select a pass-through device. But this is all like empty. What? Maybe I have to run you as an admin. Let's try that. Oh, but it already is running as an admin. Tools update driver. Tools settings. What's in here? Select a supported device, and there's literally nothing here. Hello? Why is there nothing here? Why don't you see anything? Could it be possible that this is only looking for certain adapters? That would be really frustrating if that's the case. If they only let you use certain valid adapters by Drew Technologies, otherwise, screw you, you're not able to view it. Ah, that's a shame. Looks like we're not using that then. And also, the thing is with Vimeo, come on, launch, there we go. There is no way for me to manually specify card DAC, you say? What's that? Oh yes, of course, one of their own adapters. Okay, so I'm curious if I was to select EGS52, because I know that uses K-line as well. Now what do you try doing? And again with this, it tries, what do you try? ISO 9141. I'm confused as to why it does this. Using channel open protocol 9141. Okay, I'm just going to do a very quick sanity check here and just print the flags it's trying to connect with, just to make sure I'm not doing something really stupid. So we shall quickly open up lib.rs and just quickly do log debug format and just print protocol %D. And that should be protocol ID. Oh wait, this is Rust, I need to format it like that. Okay, let's build a driver. Cool, go ahead and launch Vimeo again. So if it prints 4, it's trying to print with 9141. I was trying to open it with that. Open CR free up. Okay, what did you print? Protocol free. Yeah. Why? Why is it trying to do that? That's like illegal. I'm so confused. So here you go, ISO 9141 is 3 and ISO 14230 is 4. That's bizarre. Okay, so now I'm technically going into unfamiliar territory because this is kind of undocumented. If this is the case, that Vimeo is actually trying to do fast init on ISO 9141, because like it's kind of illegal for it to do that, but I suppose it could because it's used the same wire. Like, actually, what's the payload it sends to initialize contacts? I'm curious. 8112 F381. Okay, I shall try that in just a sec. Okay, tell you what we're going to try doing, rather than reading in a loop, we're going to use actual timeouts on serial to do this. Because all the timing parameters should be already being applied. One sec, where's the correct window with this? Okay, so after we write, rather than doing this, we do this serial, OBD serial, set timeout. And I believe in here there is a tidle, there is a timeout specification, or timeout value. Maximum ECU responses. I believe it's P1 max. P1 max, we shall set it to that. Okay, and then I'm just going to allocate a buffer of 10 bytes, just that's arbitrary. I couldn't really care less what that number actually is, so if this serial read bytes buff 1, else we're going to actually respond with error and basically say bye bye. Respond error timeout. To say we received to start the packet. Okay, virtual machine redirect device. Upload. Cool, redirect. Close Vidimo. Close Vidimo. Try it again. So this time let's see if we just receive a response from the ECU. I'll actually be curious to see what the timeout is that it thinks it's setting. Nope. So it said error timeout, so it didn't receive anything back. You know what, I'm just going to be safe rather than sorry that I've actually set the pins correctly on this. So I'm going to go to Macchina M2 schematics. So schematics and source, Macchina. This is what I love about them, right? So I can just go ahead and view the schematics for them. So M2 interface board. No, it wouldn't be the interface board, it would be the processor board. Have a look at the schematics for the processor board. Okay, now what pin is what on here is my question. So there should be LIN something, or is it UART? Okay, hang on a minute. Let's quickly go have a look at the actual interface board itself. So interface board, interface board. Current sense, low power control, 12VIO. No, this is not what I'm looking for. 12IO, 12IO, analog inputs, J1850, we're getting warm. Ah, here we go, LIN interfaces. So we want K-bus, so this is the one which you go for, so its signal is 9141KRX, 9141KSLP, and 9141KTX. Let's see if we can find these on here. Ah, here we are. And guess what? I've done all the pin numberings wrong. So that might be why nothing's happened. So, RX pin is PA9, I think. No, RX is PA10. Then TX is PA11, and EN, which is SLP. Where's SLP go? Okay, well it doesn't seem to like PA. Sorry, I've got this open on another window, some of the other stuff I'm doing, so it'll be 3 and 4. It should look like this rather than pin 18 and 19. So we shall go have a look. Cool. Let's redirect this all again. See if we get response now. Nope, still no results coming back. Are the pins correct though? So if I go to firmware.ino, I'm doing this on another monitor, I know. Actually, let's go have a look at the Macchina's M2 repository, because I think they have an Arduino repository for this where I can have a look at all the pin defines they've done there, because maybe 3 doesn't exactly map to 3 on the schematics that I've got. Let's quickly have a look. Very quickly pull this on here until I get to the correct folder. Okay, here's pins arduino.h for the M2. Oh, and it just includes variant.h. Let me open that up. Okay. M2 LEDs, okay. M2 GPIO, okay. Where's the K line? Ah, here we go, brilliant. Okay, so KTX is 55. So it would be LIN KTX, and this would be LIN KRX. And define SLP pin as being LIN KSLP. Let's do that. Virtual machines redirect. Upload this new firmware. Actually, I'm also going to get rid of these 2 bits here. I don't think I need them. Again, still not seeing any data. Do I have to do something with the SLP pin? Okay, I wonder if I have to pull up that SLP pin. So rather than that, we do SLP pin. And we write height of that. Cool, let's go ahead and try this. Nope, still not seeing any data. Oh, this is getting frustrating. Also, I think I might need to actually make it an input pull up on that pin. Also, I'm considering just ending streaming in a bit, because to be fair, this is going to be painful until I eventually work out how to fix it. I mean, do stay tuned for on Twitter though. I'll probably end up posting about it there once I get it working. But yeah, this is proving to be a bit of a nightmare. Okay. Try it again. Still nothing. Great. Okay, I think I'm going to call quits here with stream. And probably over the week... One sec, let me go ahead and show this on camera. And over the week I'm going to diagnose this, make sure that my setup's working before I actually start the stream, so that I know that K-Line is working rather than just my adapter's not working, or my code. And actually, next stream might not be even on this. Next stream might be on this little guy. Trying to get Rust working on the Tinsy for the Gearbox project / C++. Like, I want to make a hybrid API for both. But yeah, that shall be fun. Yeah, Richard, look, I'm not going to give up. I'm going to still work on this in my spare time, but just like tonight, I'm honestly shattered. Like, prior to stream, I was on a 4-hour exam, so probably not the greatest move to decide to start a stream straight after coming off a huge exam. That's probably why I'm partly so tired, but in the next couple of weeks, I should be a lot more freer, because I only have 1 exam a week rather than 2 or 3. And then just the 24th and the week beginning the 24th, I've got 2 more exams, and that's it. I'm a free man. So I suppose I'll be doing a lot more streams here, whereby I can be working on things. But yeah, anyone else has like a small question or something, just free to throw it in chat now. And also, I do have quite a lot of plans for summer for my car, so expect a few more videos going up. Thanks. Actually, I'll just do a tiny bit on here showing some of the PCB designs that we've got now for EGS. So, to be clear, I'm not actually going to release these to the public for now, until I've tested everything. So you currently have 2 versions of the PCB. One with these newer controllers, which are basically solenoid drivers for injectors, and we're using them to drive the solenoid transmission solenoids. These are TLE9104SH, but we have a slight problem with these, which is that if we go to Google and and search up these on Infineon, right? Check out this amazing backorder date. Factory lead time over a year. So yeah, probably not going to use those. So in the meantime, for prototyping, what I've instead done is, if I go ahead and change switch version to TLE620GP, and close all this down so we can switch, close this. Yeah, thanks, Richard. As usual, EasyADI does not want to load things for a while. Come on. Come on. There we go. So the new one uses TLE6. The second revision uses TLE6220GP, which you could easily find on eBay for a couple of quid. So, yeah, I'm using these for prototyping, but this wasn't a fun bit to add to the PCB. Essentially, these logic shift converters, which convert 3.3 volts, which the Tinsy speaks at, to 5 volts, which these older controllers speak at. The newer solenoid driver controllers only run at 3.3 volts, which is really good. But yeah, if I just quickly go ahead and delete these layers so you can see the actual PCB, this is what the current one, which I should have next week, look like, and all the components should hopefully be here next week. So if I'm doing a stream next week, it will be on this, and we shall probably be working with either a finished PCB which I've put together, or we shall be working with soldering it, because I've got myself a new soldering kit. I'll show that on camera actually. It's nothing too special, but you know, compared to just having a cheapo soldering iron, this is a pretty decent upgrade. Let's see. Open up the suspicious pouch, and we shall terminate this. So this is my new soldering kit. Oh wait, actually you can't see that at all. One sec. Let's see, can I zoom out? Yes, I can. This is better. So 0.3mm solder. So for tiny SMD components, soldering iron, temperature controlled. I can control that solder sucker, usual stuff. Also different bits for different bits. Yeah, just, you know, this is a good soldering kit compared to like. So basically, the soldering iron I had prior to this was from a local DIY store called Wix here in the UK, and it was literally just the fattest tip. Like the tip itself was probably about the width of my fingernail. And you can imagine, not really great for SMD soldering, so I consider this a good investment. I mean, the kit itself only cost about £30 on Amazon, and I can get replacement parts from Amazon, so yeah, it's not bad. I'm definitely looking forward to soldering all of that, and also all the pain which will ensue from trying to solder it. Also, quickly, just want to show this. But check out, so I don't know if you know from my previous streams, but I had the demo A0 from Macchina. It's like this little tiny unit. I bought the same solder. The only issues I have with it is it's very weak to solder huge ground pads. Well, I'm not soldering huge ground pads, so I should be okay. Anyway, this is the new A0, like the production one, and I've already perfected my ESP32 driver for the Passthru API so that it works on this, because there were some slight changes from this iteration to this one. So yeah, when the ESP for the Macchina A0 comes out, which should be at the end of the month, or near the end of the month, my driver's ready to go. So you guys can happily just go ahead and purchase one. And yeah, use it, but only for CAN though. The M2 is the one which got K-line, but currently K-line doesn't work. I'm working on that. So yeah, if you've got a CAN-only vehicle, you can use this. And also, I bought myself one of these. ELM327. I think you all know what's going to be added to Open Vehicle Diag at some point. I'm going to be adding support for these little doodads. It's going to be crap, but it's going to work. So that's going to be fun. The ELM327 chipset, the problem with them is that you can get so many Chinese clone chipsets, which is that they might not support a lot of the features which the real ELM327 chipset supports, and mainly also because the cheaper ones are the Bluetooth based ones, so that'll be the one I'm working with. I'm not going to use USB support for now, but we might be able to do that at a later date if I can get my hands on a USB ELM327 chipset. But yeah, I look forward to doing all this over summer, so you know, vehicle diagnostics might eventually be very easy for you guys, which is what I'm hoping. Anyway, that probably concludes the stream, so thanks again for watching, you guys, and make sure you follow me on Twitter, because I currently don't have the YouTube communities tab because I don't have 1,000 subscribers, which is really sad, so I can't update my YouTube audience on YouTube. Instead, I have to do it via Twitter, because YouTube is just like, YouTube is so frustrating. You have to have 1,000 subscribers if you want to use the community tab. If you have like near that, which I do, I'm at like 877, I think. Yeah. If you have near 1,000, tough luck, but you can't update your audience to gain more subscribers because you become more community involved. So you have to just break past this 1,000 barrier first before I can then update everyone on what's going on YouTube community tab. So until then, just follow me on Twitter. I don't really post much on Patreon, but that's just purely because I'm too busy to, so I just kind of like tweet stuff on Twitter as I'm working on it. In fact, there was something I'm recently been doing, which is just adding this cool little like notification thing to the head unit system I have in my car. Talking of which, that is a project for summer. We're going to be working back on that, except maybe with a bigger screen and custom electronics behind it. Essentially, the long-term plan for my CDI, which I have, is to just rip everything out of it and maybe eventually change it to something a lot more digital on the inside to look like a newer car, but it's all open source software, so anyone can contribute to it. And in the process, try writing some standard APIs so that if you, say for instance, have a Ford, you can just tie in all the data telemetry to the system correctly, and you're off to the races. But yeah, also one other thing, I completed my dissertation on Open Vehicle Diag the other week. I'm waiting for it to get marked, and then I shall make it public. So until then, just wait. But it's a long read. It's a very long read. It's like 130 pages. But I'm happy to get that out of the way. So anyway, that concludes the stream. Thanks very much for watching, and I'll see you in the next one. Goodbye.